Yeah, hello everyone, myself Maruti, welcoming you all to this math video session. In this video, I have taken a sum from linear equation under two variables. Alright, as you all know, as I have been telling to you in all my videos, linear equation under two variables generally deals with real life application. So, finding two unknowns, right, finding the measurement, finding the number of these things, find the cost of that, or finding the length and breadth, all the real life application can be dealt in the linear equation under two variables. Okay, in this concept I brought to you a relation between the students and benches in a classroom. Right, the relation between students and benches in a classroom. So how to set the equations, how to find the value of those unknowns, we'll come back to this. So if you read the question, in a class, if three students sit on one bench, one student is left. I repeat, in a classroom, in a class of 10, if three students sit on one bench is left. Fine, that's the first relation. The next one, if four students sit on one bench will be left. I repeat, don't get confused, I'm here. Right, if four students sit on one bench is left. It's same. No, it's not same. You take it out here. First one, what he says, if three students sit on one bench, one student is left. If you check it out, student. Right. Now, if you go to the second relation, if four students sit on one bench is left. Means student related with benches. Okay. Now, how to relate this? As I have been dealing in terms of concepts. So, what are the two concepts generally we are dealing here? According to me, students and benches. These are the two concepts what we are dealing here. So, let's go according to the concept style. So, let's go for the concept one. Right, concept one. What's the first concept here? Right, so I like to take the first concept. One of the first concept is nothing but, of course, we are having two, students and benches. Okay, so I'm taking benches as the first concept. Alright, so I'm taking benches as the first concept. Why I'm taking benches as a first concept? I will let you know. First concept, what I like to take it is nothing but the benches. Of course, concept two, I like to take it as students. Right, students are the second concept what I am going to deal in the sum now. Students and benches. Right, why did I take bench concept one as benches, and why did I deal with the students second concept? Why? Because I like to go to the logic. First logic what I am generally doing in all my videos. Okay, right, what is here? To what it is compared? To the one to which we are comparing, I like to take that as x, and which is compared, I like to take that as the y. I repeat, right, to the one which we are comparing, I like to take it as x, and which is compared, I like to take it as y. Generally we take it, is not mandatory. That is the easiest way. I like to stick on with the same logic here, right, to which it is compared. Right, I like to take that as x, and to which is nothing but x, which is compared, I like to take it as y, which is compared, I like to take it as y. Right, so, right, this is why. Now, if you check it out, students are compared. Okay, if three students sit on one bench, see here, students and benches. Right, students are compared to the benches here. How many? So, as the second one is benches, I like to take benches as x. Now, let's number of benches. Right, b x. This is what I like to take. Number of benches I like to take it x, and let number of students be y. Yes, this is what the reason. This is how we are setting the question. Concept 1 and concept 2. What are the two concepts we are discussing here? Benches and students. So I like to take benches as the first concept, and I like to call number of benches as X. I like to take students as the second concept, and I'm taking number of students as Y. Cool. Basing upon the logic 1, I have dealt with which are the two concepts and which is X and which is Y, and the question is we need to find how many number of students and how many number of benches. Obviously, always we find the number of students and find the number of benches. So if you check it out, number of benches I am calling it as X and number of students I am calling it as Y. Right, that is what. Why? Because this the relation is going. This two benches it is compared and this is compared. So I am taking like that. Cool. Now, so let's go to the first relation. What is the relation he is talking about? Right. So let's go for the relation 1. Let's take what is the relation what he has given here. Cool, cool. So what he says, if 3 students sit on one bench, 1 student is left. That's straight away what he has given. If 3 students sit on one bench, if 3 students sit on one bench, what is that? 1 student, then one student is left. Student is left. That's cool. Straight. If 3 students are sitting on one bench, 1 student is left. Right. Student. How many students on each bench and how many students are left? That's cool. Right. I like to. This is the sentence what we are having. This is the sentence what I have taken from the question. I like to convert that sentence in terms of symbols. That is, I like to go like this. I like to go in terms of symbols. What he says, if 3 students sit on one bench, then 1 student is left. Okay, now how many students are there according to him? So how many people are sitting on each bench? Alright, so according to him, what he says, if you consider these as benches, if 3 are sitting on each bench, that's what he says. If 3 students sit on one bench, if this is one bench, this is one bench, this is one bench, if 3 students are sitting on each bench, 1 student is left. This is what he has seen. So here the black color, the red colored are nothing but the students, right? So how many students are there? So if you see 3 into number of benches plus how many students are left? 1 student is left. Alright, so number of students equals how many? Right, the number of students, how many are there? So how many are sitting on each bench? If 3 are sitting on each bench, one bench means each bench. Number of students, how many number of students are sitting on? Number of students per bench. Number of students per bench, right? How many students are there? Right? Number of students per bench into times number of benches, right? Number of benches plus how many students are left? Leftover students. Leftover students. This is what? This is in terms of sentence. I have converted with the help of a diagram here. I have converted in terms of a formula, in terms of symbol. How number of students? How many number of students are there? Come on, man. Number of students per bench? 3. How many benches? Number of benches? We don't know the number of benches, but please remember, number of benches are X. Right. How many leftover students? How many leftover students are there? 1 student is left. Right. So number of benches, number of students per bench. Okay, you got it. Hope I think. number of students is equal to number of students per bench, right? That is, if you see here, I like to take an example like this. I took 4 benches, right? Example, just I like to give an example for you. So, how many benches are there? 4 number of benches are there. How many students on each bench? 3 are there. So, if 3 are sitting on each bench, that is 4 benches, 3 times 4, 12, plus 1 student is standing up. So, totally 12 plus 1, 13. 13 students are there total. This is just an example. I like to say example. This is an example. Don't think that is the answer for you. Okay. So, how did you get? So, which implies number of students is represented by Y is equal to number of students per bench. How many students are there per bench? It's 3 times, okay, number of benches. Number of benches, what did you call? It's nothing but X plus. How many students are left? Leftover students. How many leftover students are there? 1. That's cool. Right. So, number of students is equal to number of students per bench, number of students per bench. How many are there? 3. How many benches are there? X. How many benches are there? X. How many students are left over? How many people are standing there who are not even played? 1. Okay, that's cool. So, can I consider here, he has given directly the relation? Yes, according to me, he has given the relation directly. I like to call this relation as direct relation. Direct relation. Why I am calling this as direct relation? Why? Why? Because what are this? Number of students. Here, students, this is the relation he is talking about. Students and the student. He has given the relation between the students and the leftover. Right. Here also 3, something like 3, 4, 12. Here also they are students. Here also student. Student and student relation. Student and student. Student and student relation. Right. I like to call this relation as direct relation. Fine. And why? Why we are calling means number of students and the leftover are also students. Therefore, student and student are the relation. From this, I can say y is equal to 3x plus 1 is nothing but our first equation. Cool. So, hope you are able to understand. There are 2 concepts. Benches and students. I like to take benches as X and number of students as Y. Why? Because I said basing upon the logic. Right. Now I have taken the direct relation. Why I am taking the first relation as direct means he is giving relation between students and the leftover. All are students. Number of students is equal to 3 4s are 12. Of course, example 3 4s 12 and leftover. All we are talking about students only. Okay, Nana. So this is nothing but the leftover students. How many are there? 1. Now let's get back to the tricky part, that is relation 2. Relation 2. What he has given in the relation 2? If 4 students are sitting on one bench is left. While reading the question itself, you should be able to catch that. So what he says, if 4 students are sitting on bench, sitting on one bench. If 4 students are sitting on one bench, what is that? Right, what is that? One bench will be left. One bench will be left. That's what you have to remember. One bench will be left. This is the tricky part. So what he's saying, he's giving the relation between the students and the benches here. If 4 students are sitting on each bench, one bench will be left. Let's get back to the relation. Okay, now if 4 students are sitting on one bench will be left, right? Now it's a tricky part. So this is nothing but the sentence, as you all know. Now let's convert in terms of symbols. What he says, that is 4 students. Here the relation is between the student and what is leftover. Leftover are benches. He didn't give directly. He see here student and the student. Number of students is equal to the last students left over. Trade away. Now here, if 4 students, number of right, students, number of students is equal to, right, how many are sitting? Number of students per bench times, right, number of benches. That's right, number of benches. This is the tricky part. What? See here, if 4 students are sitting on one bench, right, 4 students. Here the same example I like to give, right, example I like to say, right, just example wise I'm taking 4. Now, how many are sitting on each bench? There are 4 sitting on each bench. This is what he's saying. Right. If 4 sitting on. So what he says, if number of students sitting on each bench, number of students per bench is 4. Right. How many bench times? If you want to know how many students are there, number of students per bench into number of benches, right? So there are 3, right? 4 members on each bench. How many total students are there? 4 times 3. 4 times 3. Why? Because the benches, of course, please remember what he says. 1 bench is left. This is what the relation. So 1 bench is left. 1 bench is left. Right. So how to set the relation? Here, if you check it out, here number of students are there. The relation, students are there. Okay, number of students. But he has given, right, students and benches. He is saying 1 bench will be left over. He has given the relation between the students and the benches. Here in the question, student and student, whereas here, student and benches he has given. The relation is between this. Can I call this as direct relation? If the relation is between student and student, I like to call it as direct relation. But here the relation is not between the student and the student. The relation is between the student and the benches. I like to call this as a indirect relation. Indirect relation. This is indirect relation. So this is the tricky part. How to match up? How to match up? Always we have to go to the y. It is number of students. Now let's go. Let's think in a different way. That is, see here. Right? When we are counting the number of students, what he said? 1 bench is left. 1 bench is left. Means, shall I say, how many people can sit on 1 bench? Just now we are thinking of how many students can sit on 1 bench? 4. Means, shall I say, a bench is left. A bench is left means place for 4 people is left over there. Okay, Nana. So 4 for, if I say 1 bench is left, how many people can sit on 1 bench? 4. Means, right, a place in which 4 people can sit, that is left over. A place in which 4 people can sit is left over. Right, you got it. So I like to call number of students, as you all know, it's nothing but y. Okay, number of students per bench is nothing but 4 straight away. Right, number of benches we are calling it as x. Okay, now here comes the tricky part. As we are dealing with the number of benches, benches should be dealt with benches. Benches can't be dealt with, students should be, number of students should be dealt with the number of students. Here the relation is between the students and the benches. He said 1 bench is vacant. We should not think about the 1 bench. We should think about the number of people who can sit in 1 bench. Right? So how many people can sit in 1 bench? 4 people. Right? How many can sit? 4 people can sit. Why? Because number of students and number of students we have to relate. Okay, now it is left over. Is it more or less? Right, how writer? Place is left over. Means 4 people more can sit there. Okay, but they did not sit. They did not sit. Therefore, we are taking away the place. Right, minus. Right, 4 people. The place for 4 people is left over. It is not used. Are you able to understand? Therefore, number of benches is 4. I like to call this as place for 4 people, 4 students to sit. Right, why? Because what he said, 1 bench is left. 1 bench is left means a place of 4 students. Right, on one bench 4 people can sit, therefore it is left over. Therefore the relation is y equals 4x minus 4. This is the tricky part. This is relation 2. Cool, hope you are understanding. That's why we are calling it as indirect relation. Right, here straight away student and student direct way we have added. But here student and benches he has given. Okay, so we are not taking in terms of benches, we are taking in terms of the place for the student. How many students can sit on one bench? 4. So 4 students place is left over there. Left over means minus. So 4 students place is left over. That's what the equation is. Y is equal to 4x minus 4. Right, here comes the tricky part. Now as usual, we are having equation 1 and equation 2. For find by solving the two equations, solving equation 1 and 2. Equations 1 and 2. Right, here y is equal to 3x plus 1 and here I got y is equal to 4x minus 4. I'm equating. So 4x minus 3x is equal to 1 plus 4. I'm transposing 5 is equal to 1x. Therefore x is equal to 5. Straight away we got it. Right, what is that? X is nothing but number of benches. Okay, but we need y. Substituting x is equal to 5 in any equation 1. Y equals what we are having. Y equals 3x plus 1. So y equals 3 into 5 plus 1. Y is equal to 16. Yes. But until and unless I verify, I can't give you conclusion. So what is verification? Okay, according to him, x is equal to how many? X is number of benches. Okay, how many benches are there according to him? 1, 2, 3, 4 and 5. 5 benches are there. Number of benches are 5. Number of benches. Right, comma x is equal to 5. That is what we got, benches. Okay, let's see. How many students are there? 16 students are there. Number of students, y equals 16 is the relation. What is the first relation? If 3 are sitting on one bench, let me make 3 students sit on one bench. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and yes, 1 student is left. Okay, if there are 5 benches, if 3 are sitting on one bench, 1 student is standing out. Yes, he is standing out. Relation 1 is correct. Okay, I don't want to satisfy with the relation 1 itself. I like to check the second relation also. Okay, so the same, but the number of students and number of benches doesn't change. Now, right, sorry, x and 5. But the position, how they are sitting matters. Okay, now this is right. What do we say is equation 1 satisfied. Equation 1 satisfied. Now let us check to see equation 2. If 4 are sitting on one bench is left over. If 4 are sitting on one bench, let me make 4 people sit. 1, 2, 3, 4. 4. Totally how many are there? 16. We have to distribute 16 on 5 benches now. Okay. So again 1, 2, 3, 4. 1, 2, 3, 4. 5, 6, 7, 8. Totally 12. 13, 14, 15 and 16. How many students I made to sit on each bench? 4, 4, 4, 4. How many benches are left over? 1 bench is left over. So, is the equation 2 also satisfied? Yes, equation 2 also satisfied. Don't get confused. If 3 are sitting on one bench, 1 student is left. 1 student is left. 1 student left. Equation 1. If 4 are sitting on each bench, 1 bench is left. 1 bench is left. 1 bench left. Equation 1 and equation 2. Only the tricky part. Here itself we have to left over. 1 bench is left. 1 bench means what? A place of sitting 4 people sitting there. So that's what? Place for 4 student is left. So we are going to place for 4 people. We are taking away from that. There itself we will get it. Hope you are able to understand. In this channel, I have been placing both math and science videos.